Hi, this is Shannon Seaver. Today we are looking particularly at Part B of rational numbers. On our agenda for today is to express rational numbers as decimals, and then in reverse of that we're going to express decimals as rational numbers as in the form a over b. So on the first one that we have here, we're going to express these rational numbers as a decimal. And really what you need to do here is to use long division to divide if you do not have a calculator. And so we're going to take 8 and we're going to put that into the number 5. Now obviously 8 does not go into 5. So what we're going to do is put some decimals in, and I'm going to put a 0.0 and we'll go from there. So first of all, 8 goes into 50 5 times. So 5 times 8 is 40. And then I can subtract. And notice that 10 is actually more than 8. So I picked the wrong number. I need to go up one. So I'm going to try this over here. Remember with dividing decimals or dividing anything, it's really a guess and check. So now we'll try 6. 6 times 8 is 48. So 50 minus 48 is 2, and then now I'm going to bring down the 0. 8 goes into 20. It goes into that twice. 2 times 8 is 16. I have 4. And notice that I still have this remainder, and I can add another 0 and bring that down. 8 goes into 45 times. So notice that I have a decimal here. I'm going to put that decimal right on top in front of the 6. It's directly above where it was next to the 5. So our answer on this is 0.625. On the next one, what we'll do is take 11 and we're going to put that into 7. I'm going to go ahead and put a 0.0 here. So 11 goes into 76 times. 6 times 11 is 66. If I subtract it, I get a 4. So we want to end with a remainder of 0. So if I keep going, I'm going to add another 0 and bring it down. 11 goes into 40 3 times. So 3 times 11 is 33. And that's 7. I add another one, bring it down. We're back to 70 again. And notice that we're going to keep repeating this. And it keeps going over and over again. Notice that there's a decimal point here, so I'm going to put mine here. And this is what we call a repeating decimal. So I would actually write this as 0.63 and put a bar over both the 6 and 3 since they're repeating over and over again. Now you should stop the video and try this one on your own and come back and check. This is the answer that I got on Part A was 0.375, and Part B was a repeating decimal again, 0.45 repeating. So now we're going to go the other way. We're going to be looking at decimals and putting that into fraction form. What I would like to do here is I'm going to say try to get rid of my decimal, and I'm going to multiply this by 10. The other way to look at this is in the 10th place. So I'm going to put 7 over 10 here because it's in the 10th place. Notice on this one we have 2 zeros, so there's going to be 2 zeros on the bottom. That's a hundredths place, and then it'll be 49 on the top. And this one is 1, 2, 3 places, or 3 zeros on the bottom, and this would be 48 on top. Notice that 7 tenths I can't reduce, 49 tenths I can't reduce either, but 48 1,000ths I could because it's divisible by 2. So we'll try that. This will be 24 over 500, and notice I can still reduce that because I can divide both top and bottom by 2. So this will be 12 over 250. Again, I can reduce by 2. 6 over 125. And this would be actually not even my final answer because look, I can divide. Actually, that is my final answer. So there you go. Okay, so now I want to show you guys how to do expressing a repeating decimal in AB form. This part you're going to want to write down because there's a lot of steps to this and it's kind of complicated, and you're going to need to know how to do this for our test that we have coming up. So I want to give you the example of expressing 6 repeating as a quotient of integers. So our first step is to let n equal 0.6666666 repeating. You're going to do this with all of these repeating decimals. Always just let the first step, let n equal that without the bar, and just repeat it. Step 2, in this case, if there's only one repeating digit, then we're going to multiply both sides of the step 1 by 10. So I'm going to take 10 times n and 10 times repeating 6. That ends up being 10n equals 6.6666. Step 3 is we're going to take both these equations, this one and this one. We're going to subtract the first one from the second one. So we have 10n equals 6.666, and we're going to subtract n equals 0.666. What this does is it helps us to get rid of all these repeating decimals, because when we subtract it, those all disappear. So what we're left on this side is just a plain 6, and on this side we have 10 minus 1 basically, and that ends up being 9n equals 6. And finally, on the last part, we're going to divide both sides by 9. So here we have 6/9, and if we reduce that, we have 2/3. So 2/3 is the same as saying 0.6 repeating. I want you to practice this, because this is not all that easy at first, and see if you get the same answer that I do. This is the answer you should have gotten, is 2/9. Let's try a little bit harder one. We're going to take 0.53, and notice that when you repeat it, it's going to be 535353 repeating. So we're going to do the same thing that we did in the last one. With step 1, we're going to set n equal to that. But because there's 2 repeating digits on this one, we need to multiply by 100 because it has 2 zeros in it. So 100 times n and 100 times 0.53 repeating would be the same thing as 100n equals 53.53 repeating. So we're going to take, step 3 is the same as what we did in the last example, where we take the first equation and subtract that from the second equation here. So notice that the repeating decimals all disappear again, so we're left with just 53. But on the left side, it's 100 minus 1n, so it's going to be 99n. And then when we solve for n, it's 53 over 99. So now it's your turn again. Try to see if you can do this on your own too. So in this case, we got 79 over 99. It's not something that we can really reduce, and so that is our final answer. So that is it for this recording. If you have any questions on this, please bring them to class.